In this question, we're going to look between a line that intersects the chord, and one of the circle theorems, or the very last circle theorem, states that when a perpendicular bisector cuts the chord, it must pass through the center of the circle. So as you can see from the diagram, that's exactly what we have. So let's take this question here. The points P and Q lie on a circle with center C, as shown in the diagram. The point P has coordinates -7, -1, and the point Q has coordinates 3 and -5. M is the midpoint of the line segment PQ. The line L passes through points M and C respectively, hence find an equation for L. And given that the y coordinate of C is -8, hence show that C x coordinate is -4, and lastly we need to find the equation of the circle. So let's start off by finding the midpoint of PQ. So I'm going to write here very clearly for the examiner, this is the midpoint of PQ. Now it's going to be x1 plus x2 over 2 followed by y1 plus y2 over 2. So in our case we get -7 plus 3 over 2 followed by -1 plus -5 over 2, and that will give me a midpoint of -2 followed by -3. Now what we want to do is find the gradient of PQ. So we're going to say that M, which is the gradient of PQ, like so, is y2 minus y1 over x2 minus x1. Now in our case we're going to get -5 minus -1 over 3 minus -7. So that gives me -4 over 10, hence -2 over 5. So now what we want is, if we go back to our diagram, we want to find the equation of line L. That's a perpendicular bisector that goes through the center of the circle and through the midpoint. And don't forget, it's at a right angle. So we're going to find the gradient of the perpendicular line. So I'm going to say that the gradient I'm just going to write it in words of the perpendicular line, or of the perpendicular bisector, let's say, of the perpendicular bisector, colon, is simply -1 over -2 over 5, which is simply 5 over 2. Now, in order to work out the equation of the line, we need to know what x1 and y1 are. Let's go back to our diagram. So notice that the perpendicular bisector also passes through the midpoint, and we have that x1 is -2 and y1 is -3. So we can say that x1 is -2 followed by y1, which is -3. Let's go back and check those coordinates. Yes, it's correct. And don't forget, M in our case is 5 over 2. So we can say y minus y1 is m times x minus x1. So that's y minus -3 is 5 over 2 x minus -2. So we're going to tidy up the algebra here. So we're going to get y plus 3 is 5 over 2 x plus 2. Now in algebra, or especially in A-level maths, or in maths in general, we don't want a fraction, so we're going to times throughout by the denominator. So we get 2y plus 6 equals to 5 bracket x plus 2. Now we've got to expand the brackets out here. So we get 2y plus 6 equals to 5x plus 10. So you can have this in multiple ways, but I'm just going to write it as 5x minus 2y plus 10 minus 6 equals to 0. And so one version of that equation of line L would be 5x minus 2y plus 4 equals to 0. Now part B says to show that the x-coordinates of the centre C is minus 4, given that the y-coordinate is minus 8. So we're just going to simply substitute the y-coordinate in. So we're going to say when y is minus 8, 5x minus 2 times minus 8 plus 4 equals to 0. 5x plus 16 plus 4 equals to 0. 5x plus 20 equals to 0. 5x equals to minus 20. Divide by 5 on both sides. Therefore, we have shown that the x-coordinate of the centre is certainly minus 4. So, which implies centre is minus 4 followed by minus 8. Now, they want the equation to circle for the last part of the question. So what that means is we need to know what the radius is. So I'm going to draw the radius. So by definition, it's from here to here, from the centre to the circumference. Call that r. Well, we know what that is. So p is minus 7 minus 1. So I'm going to write that down underneath that. So p for my diagram was minus 7 minus 1. And the distance formula we can use here, I'm going to say is r squared. I'm just going to write it in full form first and substitute x1 minus x2 squared plus y1 minus y2 all squared. Just using Pythagoras between 2 points to find the distance of the line. So hence we find the distance, we're finding the length of the radius. So r squared in our case is minus 4 minus 7 squared plus minus 8 minus 1 squared. So r squared will work out to be 3 squared plus minus 7 squared, which is 9 plus 49, which is 58. So we got r squared to be 58. Now, don't forget the equation of a circle. With the centre in general to be AB is always x minus a all squared plus y minus b all squared equals the radius squared. Now we know what our centre is. Our centre is at minus 4 minus 8. So therefore the equation of the circle is x plus 4 all squared y plus 8 all squared is equal to our radius squared, which is 58. And that's the equation of the circle. Here's a question for you to try. You can pause the video, and when you're done, you can watch my worked solution. Okay, welcome back. So the question states we got the points R and S that lie in a circle with the centre A in minus 2 as shown in the diagram. The point R has coordinates 2 and 3, and the point S has coordinates 10 and 1 respectively, and they both lie on the circle. Now, M is the midpoint of the line segment RS. The line L passes through M and C, hence find the equation for L. find the value of A, and find the equation of a circle. This is literally identical to our last example. The only difference now for part D, we need to find the points of intersection, which is quite a nice question for you to try, because altogether the question is worth 4 plus 2, which is going to be 6, plus 3 is 9, plus 5 is 14 marks. A lot of marks there. So it's good for you to get that exposure to exam style questions. So let's have a go at this. So the first thing we ought to do is to work out the midpoints. So we're going to do that as we did previously. So I'm going to say midpoints of, let's go back to our diagram. Our chord is RS. So that's the midpoints of RS. Same formula as before. So x1 plus x2 over 2, y1 plus y2 over 2. So, and what we get for the midpoints is 6 and 2. So now we want to find the gradient of RS. And again, it's y2 minus y1 over x2 minus x1. So now I get 1 minus 3 over 10 minus 2, and that gives me minus 1 over 4. So we get the gradient of RS. So don't forget, the perpendicular bisector is line L, and that's what we're interested in working out. So now we need to say the gradient of the perpendicular bisector. So the gradient of the perpendicular bisector. Now pay heed to my headings and the way I have made my working out lucid for the examiner. You must do exactly the same when you write your exam. So now it's going to be minus 1 over the gradient we found, and we get positive 4 as our gradient. So now if we go back to our diagram, the perpendicular bisector passes through the midpoints, and we have those coordinates 6 and 2 respectively. So we can say the equation of line L is y minus y1 is m times x minus x1. So y minus 2 is equal to 4 times x minus 6. So y minus 2 is 4x minus 24. So our equation of a line L in the form y equals mx plus c is y equals 4x minus 22. I'm just going to leave it in the GCSE format, y equals mx plus c, because we need to work out a coordinate for the next section. So it now says find the value of a. Well, the center lies on the equation of line L, and we know that y coordinate is minus 2. So let's do a substitution. So when y is minus 2, so minus 2 equals to 4x minus 22, 4x equals 20, so our x coordinate is 5. So now we can say that the center of the circle respectively is at 5 and minus 2. So now they want the equation of the circle. We now have the center. We need to now work out the radius as we did last time. It's defined from the center to the circumference of the circle is the radius of the circle at that point. So I'm going to use C and R. R is 2 and 3. So I'm going to write it here. R is 2 and 3. So you're going to find R squared. So that's going to be 5 minus 2 all squared minus 2 minus 3 all squared. So the radius squared works out to be 3 squared plus minus 5 all squared. So the radius squared is 9 plus 25, which is R squared, or the radius squared, is 34. So we can then say the equation to the circle, we have to center part C is x minus 5 all squared plus y plus 2 all squared equals to 34. Now part D says to find the points of intersection A and B of the line L and the circle, and it's 5 marks. So now what we have the equation of line L, and we're going to substitute that into our equation for circle. So we now have line L to be 4x minus 22. So then for part D, we're going to get x minus 5 squared, right in our y equation, which we found earlier was 4x minus 22. So we write that here. Plus 2 all squared equals to 34. So x minus 5 all squared, and that works out to be 4x minus 20 all squared equals to 34. So that works out to be x squared minus 10x plus 25. We'll just do this one here. So plus 16x squared. Well, 4 times 20 is 80, times 2 is going to be minus 160x. 20 squared is 400. And that's equal to 34. So what we get is 17x squared. That gives me minus 170 plus x there. I'll write that a bit more clearer. Plus 25 minus 34 plus 400 equals to 0. And now what we end up with is 17x squared minus 170x plus 391 equals to 0. So divide it all throughout by 17. So we get x squared minus 10x plus 23 equals to 0. We can use the quadratic equation here. So we can say that x is minus b plus or minus b squared minus 4ac all over 2a. So x is 10 plus or minus 10 all squared minus 4 times 1 times 23 all divided by 2 times 1. Now solving our quadratic, that simplifies to be the following: 5 plus or minus the square root of 2. So we can find our subsequent y coordinates when x is 5 minus root 2. We substitute it into our equation. 4 bracket 5 minus root 2 minus 22 works out to be minus 2 plus 4. Let's expand the whole thing out first and then simplify it. So I get 20 minus 4 root 2 minus 22, which works out to be minus 2 minus 4 root 2. You write down what that is. That's 5 minus root 2 followed by minus 2 minus 4 root 2 as our first point of intersection. And then when x equals five plus root 2, do the same thing. Y equals to 4 brackets 5 plus root 2 minus 22. So I get 20 plus 4 root 2 minus 22. So I get minus 2 plus 4 root 2 as my y coordinates. So overall, I'm going to get 5 plus root 2 followed by minus 2 plus 4 root 2, and we're done.